world's first living robots. That's right, these micro-machines are in fact brand new programmable life forms that researchers believe could help clean microplastics from our oceans or even repair organs inside our bodies. Measuring less than a millimeter wide, these xenobots, as they're formally known, were created by researchers from the University of Vermont and Tufts University. Using stem cells harvested from the embryos of the African clawed frog and a sophisticated computer algorithm, they generated a blueprint design that allowed the team to then build a new form of life that has never existed before. Stem cells were first differentiated into skin and heart cells. The skin cells were chosen for their capability to bond together to form the passive architecture of the xenobot, while heart cells were selected for their ability to contract and relax, with the goal of manufacturing a type of tiny engine that would propel the xenobots. After observing the natural dynamics between the skin and heart cells, the data was fed into an evolutionary algorithm run on a supercomputer. Based on this data, the algorithm was able to generate millions of different cell configurations to test for a desired outcome, in this case, locomotion. And so began the test for survival. Only the fittest configurations advanced to the next stage, where their designs were then crafted into better digital models, microsurgery on heart and skin cells to create their novel organisms. Novel organisms. And voila, the researchers created their first xenobots. The biobots could propel themselves, moving in straight lines or in circles. They could work together, herding loose particles into tiny heaps. And when cut open, the xenobots healed themselves. Cells are incredibly intelligent. There are still so many things that we don't know about how they work. Like, how do they communicate to build complex bodies, or even heal? If we could decode those signals, scientists could build smarter robots with pre-programmed tasks that would be biodegradable and biocompatible. And these little xenobots are just the first step in figuring out how to control anatomy on demand. I mean, just imagine all the applications of this type of research. If scaled up, xenobots could be used for regenerative medicine like repairing organs or growing body parts for transplant from the ground up. They could be created using a patient's own cells, then inserted into their bloodstream and programmed to clear the plaque from clogged arteries or to detect cancer. But the applications aren't just limited to the medical field. The team also envisions assigning individual tasks to a swarm of xenobots to collect microplastics from the ocean or search and collect radioactive contaminants. Now, a world full of custom, planet-saving xenobots sounds really cool, but you may have already asked yourself about the ethical implications for creating a totally new form of life. And you're not alone. The team has fully acknowledged that future iterations of xenobots could include nervous systems, blood vessels, or even reproductive parts. And it's these additions that are prompting many to wonder if xenobots should be considered more than just machines. There's also the tiny fact that the research is partially sponsored by DARPA's Lifelong Learning Machines program, which again has left some observers questioning the future direction of this research. However, the research team is open and encouraging of these ethical discussions in the public domain, in the hope that policymakers can keep up and implement the right regulations as this science progresses. Right now, the xenobots are still really basic and currently restricted in their reproductive abilities. And in terms of scalability, as we've just learned, these bots aren't exactly easy to create, requiring hours of microsurgery just to create one. The next phase of the research is to develop a xenobot capable of carrying a payload using a patient's cells to deliver medications deep within the human body without eliciting an immune response. So ultimately, these xenobots are just the first steps in trying to understand how life starts, perhaps one day providing scientists with the ability to control exactly how life forms. For more robotic topics, check out this focal point on a robotics lab that's investigating the idea of artificial consciousness.
You know, when you look at other things as well, such as DARPA's hydrogel.
At DARPA, I am an active duty Army infectious diseases physician and have specialized in addressing biological threats that can either be engineered or naturally occurring, such as Ebola or pandemic influenza. Today we're going to be talking about one of the technologies that I actively manage, a company called Profusa, which is aiming at achieving tissue-level continuous health monitoring. Through the SBIR program, we funded them to solve an incredible technical challenge that no one else had been previously able to solve. The key innovation that was presented to us is they said, why can't we make a chemical substance that's really identical to what's underneath the skin, what we call the subcutaneous tissue, so that your body doesn't recognize it as a foreign body response. It just incorporates itself into the tissue. And we have a lot of examples now where a sensor put right underneath the skin can sense things like oxygen and other chemicals that are very important to our metabolism. And not just sense that for a day or a week or even a month, but we imagine that sensing these parameters can go on for a period of years. One of the most important applications to us is so that we can improve the health of our worldwide deployed military force. We feel a strong sense of obligation that if we're going to ask somebody to be deployed and to carry out their mission, that we want to keep them healthy. And this technology will give us a way to monitor if someone is getting sick. We imagine that we would be able to sense that very early and therefore prevent them from getting sick and prevent their complications, allow them to stay healthy and continue to carry out their mission. In addition, if our technology translates into general health benefit, we're very excited about that. So, in other words, we fund those national security applications. The company finds private sector partnership funding for that general health benefit. And we see it as really a win-win as this technology develops.